Welcome to Brown University Computer Science course CS148, Building Intelligent Robots. I'm the instructor for the class, Professor Chad Jenkins. In this course, we cover all the various aspects for building autonomous robots. In this approach, we don't really focus on the engineering aspect of actually constructing physical robots, but we focus on the computational side. What do we need to do? What algorithms do we need to develop in order to make these robots work and play things on their own? What we have right now is our robot soccer field. This is our robot platform. It is a iRobot Create. It's the same thing as a Roomba vacuum cleaner, except it doesn't have a vacuum, so it's the Roomba that doesn't suck. And then what we do is we put a sub notebook on top. So this is an Asus EEE PC and a Logitech web camera. And this does the computation. So this is the brains for the robot. We program this robot using either the player stage robot middleware package or the robot operating system, the ROS.
Here we're capturing the image through the USB support, and what we're doing is creating an image message, which is processed in ROS and then sent to OpenCV. And what OpenCV does is basically captures the image or video and displays it on your screen.
What we do is we explore the class through a number of projects to get you situated with the robot, to get you familiar with the basic functionalities, and then through three or four robot soccer projects. If you can do those things, then you can do the basic robot soccer task, and you can do pretty much any task in autonomous robotics. The first project is just to have the robot run around and bump into walls, and this is called the Enclosure Escape project. The next step is to do an object-seeking assignment. And in this assignment, we take some of the objects of interest, and we just want to have the robot find these objects and go to these objects in a certain order.
This project entails calibrating on color to be able to recognize the objects. Bounding boxes will be returned by the blob finder proxy from the player middleware package. And in this assignment, they use a finite state machine to continually seek the objects and drive to them.
Once you're able to find this ball and the various objects on the field, you're ready to play robot soccer. And in robot soccer, what we do is we first start off with a path planning assignment. And we have 4 overhead cameras that cover the space of the field. And these overhead cameras provide a bird's eye view of what's happening on the field. And the way it knows where the robot is it uses these augmented reality markers, like a 2D barcode.
So here we have a graphical image called Smurf Stadium that actually displays what the overhead localization sees right now. So in this assignment, we provide the overhead localization, so that's like the GPS for the robot. They're also given positions of obstacles from the overhead localization and from the ball. So the goal is to plan a path from the start location to the end location, which is the ball.
Then the next assignment is to say, well, we have a working path planner. Let's take away the overhead localization system. Let's take away the GPS. Then you have to write your localization routine on your own. So given localization and path planning, you've built a deliberative system that builds a model of the world and thinks about what it should do in order to accomplish some goal, which is in this case, actually scoring a robot soccer goal. Then we take it to the next level and say, you can't store any information on your robot. The robot has to react only to its current circumstance. And when it does that, then what we have is called a reactive controller.
This is the subsumption project. Unlike the previous assignments, the robot is not able to keep track of any state variables, any history. It has no idea where it is in the world. So it uses a subsumption architecture, and based on what it perceives in the current state of the world, it makes a decision on what to do based on a priority.
And then typically what we do is we take this whole setup, and students get used to working in the lab and used to this setup, and so we try to throw them out of that reality into something a lot more difficult. So we try to find some new environment. So last spring we ran in the Petaruti Lounge at Brown University with a much larger field, and we had 2-on-2 robot soccer. Our robots are still very sensitive to various environmental conditions, such as lighting and shadows. So this poses very interesting questions about how robots can perform in environments where humans actually live. If you take CS148, it's a good opportunity to take what you've learned in computer science, or even if you're new to computer science, to get a feeling for what robotics has and why is it different than standard computer science. And right now we're really at a new point where robotics is going to really take off. I believe so. Robotics is a lot like where personal computing was 30 years ago, where computer graphics was in the 1980s. I think in the coming years you're going to really have lots of interesting robotic devices and lots of interesting robotics products that have come along. And so taking CS148 is really, can be your first step in terms of making that happen.